First of all, thank you for joining. My name is Sohan Maheshwar. I work for a startup called Authorized. I have 15 plus years of experience working in cloud and emerging tech, and I'm based in Amsterdam, in the Netherlands. And today, I'm going to talk to you about securing rack pipelines using fine-grained authorization. We have a lot to cover today, so I'll give you a bit of context about the history of authorization, focusing specifically on something called Google Zanzibar, which is what Google uses for their internal authorization system. I love trivia and fun facts, so I'll have a small break for that, with prizes, of course. We'll talk a little bit about rack pipelines, then we'll spend most of the time looking at techniques for securing your rack pipelines, followed by a quick demo. I'm going to start with a small trivia question, but I'm warning you, if you know the answer to this, you might be an old person. All right, so I'm warning you. Does anyone remember this? Oh, can you see it? Yeah. Does anyone remember this tool? Early 2010s, made a lot of noise online. It says circles on top. Anyone? No? All young people in the audience, I think. Yeah? Absolutely no one? OK, I must be the oldest here then. So this was called Google+, Google's attempt at a social network. It was very different from like Facebook and Orkut and MySpace in the sense that you could create circles of people. Right? So if you said, these are my university friends, these are my school friends, these are my work buddies, and you could share different things with different circles. Now, the thing is, as a social network, it didn't really take off. We don't use this anymore. But the interesting thing that came out of it was Google internally changed how their authorization systems worked. Right? And if anyone has used Gmail and Google Docs and you've seen something like this, you might be surprised. So say you attach a Google Docs link in Gmail, and there's a pop-up that actually says, hey, have you shared this, or have you given this person access? If you think about this, this is actually magic because Gmail and Google Docs are two different apps, yet they're able to do a permission check in between. And this is thanks to Google's internal authorization system called Zanzibar. I'll get to how that works, and we'll do a deep dive on that. But let me give you a quick primer on the world of authorization. Now, first off, let me tell you the difference between authentication and authorization. Authentication is identity, who you are. So when you use LDAP or Entra ID or Okta to be like, OK, this person is who they say they are, that is authentication. Authorization is permissions, what comes after that. So once we have verified your identity, what can you access? Now, in the past, people have done authorization differently. Early on, there were what was called access control lists. So say you had a document, you had this huge list of all the people who could read that document. And you had another list of all the people who could edit or write that document. This, of course, wasn't very efficient. So everything moved towards something called role-based access control. Now, you probably use something like this in your business or your company, where, say, your role is software engineer, then you can check in code into your code base. Or if your role is sales, you can read quarterly reports. The problem with roles are it's too coarse-grained. Right? It's very wide. So say your sales guy wants to check in code, then, well, you have to create a new role. And I don't know if that happens at most companies, but there is a possibility. And things changed a little to evolve towards something called attribute-based access control, where every decision on permissions was based on a list of attributes. So if I had to access a document, my name, my email ID, which office I'm accessing this from, my IP address, all these things are different attributes. And at the time of decision, all these attributes are taken into account, and a decision is made, saying yes or no. And this works very well, but at scale, it can get a little complex. Now, of course, Google being Google, and it has planet-level scale, they wanted to actually have authorization for all their internal services. So they came up with something slightly different. And the reason we know exactly how it works is because in 2019, they released this white paper, also confusingly called Google Zanzibar. Now, this is a great white paper. It's written in very readable English, so I suggest you read it. It's about 12 pages. And in it, they actually describe in detail how their internal authorization system worked. The cool thing is, the first two words of the paper, right, consistent and global, makes it very interesting, and we'll get to that in a bit. But even in 2019, they said that they could do more than 10 million client queries per second, which is very impressive. From a developer's perspective, such as you and me, all we have to think about is it's an API. And this paper popularized this concept of ReBAC, or relationship-based access control, which was a different way of looking at access control. So instead of a list or a role or an attribute, everything was a relationship from one thing to another. So let's take a look at how that works. So say you have a document called Steal the Moon, and that's in a folder called Evil Plans. There is a relationship between the document and the folder, in the sense that the document exists in the folder. And say you have a user named Gru, there is a relationship between that user and a folder. And hence, there is a relationship between the user and the document. And according to ReBAC in Zanzibar, you can have relationships between users. So you have a user ID. So if anyone has a Google account, you have a user ID, and any object. So this could be a folder, it could be a document, it could be a YouTube video. And you draw relationships between these different things. And these relations could be between any object to anything else. For instance, a user could be a member of a group. They could be an editor of a document. They can be an uploader of a video. Right? So you have a user, and you have some relation to an object. So now that we have this, we need a way to represent this information so that we have it in code. And the format that Zanzibar came out is, it's called a relation tuple. Right? And it's expressed in something that looks like this. Now, this might be confusing to read, and totally blame Google for this, but you start with the hashtag and look at what's on the right-hand side. So user number 3 is the owner of the document number 123. So that's the way to express the relationship between a user and an object. The cool thing about this is it gives you a lot of flexibility, because objects can relate to other objects, but objects can also relate to other objects' relations. Right? So you can actually have very complex representations using this format. So here, again, we start to the right of the hashtag, and we say the group security is a member of the group engineering. Now, this makes sense. Think of it at work. Suddenly, you have an organization change where there's a new leader brought in, and if you have role and access-based control, that can get complicated. But in a relationship-based access control, all you do is the changing of a tuple, where you say, oh, this group now belongs to this other group, and then all your permissions fall into place. But what are we really doing with all this data? Well, essentially, we are building a directed acyclic graph. If you look at like computer science theory and things, it's very easy for computers to process data when you look at graphs and nodes. So essentially, with that relation, you are building a directed acyclic graph. Taking the example of Google Docs again, say you have a document, you have readers, so Fred and Kim, and you have a writer, Jill. You will notice a thin dotted line between reader and writer, which means that all the people who can write to a document can also read the document. So again, this is more efficient than having separate lists for reader and writer. And like I mentioned, this is flexible. So say you're like, OK, we have reader and writer, but now we have a new requirement of adding an organization to every document. You essentially just add that as another relation. So here at the bottom, you see we have added an org. We call it Acme Inc. And we say in that org, there is an admin. And every admin is a writer. And we know that every writer is a reader. So essentially, we're building this directed acyclic graph. Now, if you want to check for permissions, what happens? Right? So let's take the example of we need to check if Jill can read some document. So essentially, you're calling a check API to say, this document named some document, can Jill read this? The idea with this directed acyclic graph is if there's a way to go in one direction from the document to Jill, that means that there is permission. So here, through the dotted line, we can actually go from some document to reader to writer to Jill, which means Jill can read this document. If you look at the same way from Fred, Fred does not have write permissions to this document because there's no unidirection from some document to writer to Fred. On the other hand, Niv does have reader permissions because, again, we can draw a unidirection from some document to reader to Niv. And essentially, this was the thinking behind relationship-based access control and Zanzibar. Now, when I explain this, or when I talk about this, the first question people ask is, hey, surely this is not scalable. But you actually might be surprised because this was essentially built for Google's planet-level scale. And how they do that is in the architecture, of course, and that is an entire talk in itself. But the concise version is two things. One is every problem is broken down into a subproblem, and everything is aggressively cached for faster response. So for instance, we want to break down things into subproblems here. So going back to the previous example, when this check is made, the first check actually goes to reader, and they are like Fred and Kim are direct readers. It comes back. It goes to writer. It says, OK, Jill can write and hence can read. But the result from checking reader, Fred, and Kim is already stored. So next time, say, there is a request for is Fred a reader, that subproblem has already been cached in the data store. Right? And that level of aggressive breaking down into subproblems and caching it in different nodes is what makes a Zanzibar system very, very efficient. Now, this came out in 2019, and it made waves in the security, in the IAM space, because it popularized the concept of ReBAC. We now knew how Google actually did this internally. So companies started building their own internal authorization systems based on the Zanzibar paper. So Carta, Airbnb, all these large enterprises, they've built their internal systems based on that. At the same time, there was also the open source community who were building frameworks and tools and software based on Zanzibar. Because how Google does it is specific to Google, and then people build open source so that the rest of the world can use it. A good example is Prometheus, which actually originated from a Google white paper. The most famous example probably is Kubernetes, which also originated from an internal system at Google. But the lineage, of course, goes Google does something, they document it in a white paper, and then the open source world builds upon it so that the rest of the world can use it. Currently, there are 4, I would say, famous, at least, open source implementations of the Zanzibar paper. We have SpiceDB, we have Ori, we have OpenFGA, and Permify. And in today's demo, I will talk about SpiceDB. SpiceDB was created and is maintained by the folks at AuthZed, but it's grown into a larger project, which includes contributions from Red Hat, Adobe, Reddit, and so on. And the one metric that matters for us as developers is GitHub stars, so 5,700 GitHub stars. I'll talk a little bit about what SpiceDB is, because it took all the principles of Zanzibar, and it made it available to us as developers. So one, it is a database, but it's not a general-purpose database. So you can't use it as an RDBMS. It's meant specifically for authorization queries. And how you would do authorization in SpiceDB is, and it's written in Go. So first, you would read and write schema. Essentially, the Zanzibar paper describes schema as the definition of the objects and the users. And essentially, you can take any use case you have. So say you're on finance or a SaaS software, or you're building a social network, you can take that use case and represent it in the schema. So going back to our classic Google Docs example, so you say something like a user is a writer of a document. The writer can read and edit a doc. So how do you represent this in schema? So you define a user, and hopefully you can see it at the back there. You define a document, and then you define the relation between the user and a document. So in line 3, you can see there, it says a user can be a writer of a document. And in line 4, you can say a user can also be a reader of a document. And then for each of those relations, you can define permissions. And very interestingly enough, the Google Cloud's IAM is also based on Zanzibar. It's a fork of Zanzibar. So Google Cloud IAM, of course, is very complex. So all of those different use cases are also represented in schema. Right? So this can be very powerful even for complex use cases. Once you have a schema, essentially, you want to create, read, update, and delete relationships. Right? This is ReBAC, so the crux of everything is creating relationships. Going back to the same example, we have a document, we have readers, we have the same document, we have writers, and you represent that in a tuple. So you can create this relationship saying Jill is a writer of this document. You can delete a relationship, you can update a relationship, and so on. And lastly, of course, you want to check if someone has permissions. Now, there are 3 different things you can do in check permissions. The first one is, of course, check permissions. No spoiler there. So you want to check, OK, is Niv a reader of some document? It goes through the graph. You're like, sure. But you can also look up subjects. You can also say, give me all the subjects who are readers of some document. And then it would give you all the names you see on the left. Or you can say, who are all the writers of some document? And it would give you Jill and Niv. And lastly, you can also look up resources, which is a reverse lookup. So you can say, hey, give me all the documents that Jill can read, or give me all the documents that Niv can write to. And then it goes in the same graph, but in the reverse direction. Now, remember this because we're going to refer to it in the demo. So we have this interesting new way of doing authorization that is very fine-grained. And we know from the fact that it works at Google that it works at scale when there is a lot of data. And now we have this new thing coming up called a RAG pipeline, which coincidentally has a lot of data, needs fine-grained authorization. So these 2 things work really well. So I'm going to talk a bit about RAG pipelines, but before that, quick trivia break. Any trivia fans in the house? I am. OK, anyone is OK. Again, I'm clearly showing my age here because I'm going to talk about a band from the 70s that I hope you all have all heard of. But anyone a fan of the Beatles here? Or am I the few of y'all? Excellent. OK. Whew. I was like, man, if this is a Gen Z crowd, no one's going to know of the Beatles. OK, so this is a famous album EP of the Beatles. You all might have heard the song, All You Need Is Love, Love Is All You Need. It's pretty popular. Does anyone know what this has to do with large language models and generative AI? It's actually a very interesting story. Anyone? There are prizes. I have some swag to give away. OK, I'll give you the story. So in 2017, and you might have heard this story, but I'll repeat it anyway. In 2017, like 8 students were working on a paper, and it was about this new thing called the transformer, right? And essentially, the transformer was a new architecture for something called the attention mechanism for natural language processing and large language models. Now, they didn't have a name for the paper, and one of the students was a British student, and he was a fan of the Beatles. So the night before, he was like, hey, look, we are going to be talking about this thing called the attention mechanism. So let's name it Attention Is All You Need, because he loved the Beatles song, Love Is All You Need. And this paper is sort of one of the most cited papers right now, which has, it's improved, and it's the basis of the large language models and LLMs that we use right now. Right? So if you're using ChatGPT, the T stands for transformer. Any AI tool you're using probably has some lineage to this paper, and the name actually comes from a Beatles song. Just thought I'll mix it up with some trivia there. Now, this paper, we know how it went. We know about ChatGPT. Everyone and their grandma is using AI right now. And in 2024, there was such a rush to actually implement AI in production, right? And I really feel in 2025, we are thinking about, OK, we have done proof of concepts. We have done our research. How do you do the ops around AI? And essentially, that could be me. And essentially, there are a few ways you can do the operations around AI, and security is one of them. Some ways people are implementing AI right now is RAG, LLMs, agents, MCP is new, but today we'll focus on RAG, or Retrieval-Augmented Generation. Now, very short summary of RAG is it's an architectural approach, where essentially, say you have a large corpus of data in your company, right? Documents, data, we all have that. Now, instead of training a model specifically on that data, you use an existing model, and you augment that model with domain-specific knowledge from the data that you have. So instead of retraining a new model or getting an old model to hallucinate, you're improving an existing model with some domain-specific knowledge. So that essentially is called Retrieval-Augmented Generation. And we're really seeing a large uptake in RAG right now because people are trying to build chatbots that would connect to people's internal data, right? Where you have some internal data that's domain-specific that you want to give as output or get someone to query for. The thing, though, is we're using LLMs in production, but we don't know yet some of the risks that actually follow using LLMs and generative AI in prod. And in fact, OWASP, who is here, by the way, downstairs, you should meet them. It stands for Open Worldwide Application Security Project. It's a community industry standard. They publish top 10 lists for security for web apps, for LLMs. And they, in November 2024, they actually published a list for security risks for LLM applications. In that list, a couple of things that I think popped out were sensitive information disclosure, where you asked a question and it gave some data it wasn't supposed to. Excessive agency, where an AI agent accessed things that it wasn't supposed to. And also vector and embedding weaknesses, where people could inject malicious code into a vector database to get information that they weren't supposed to. So I think all of this falls under the, hey, how do we think about AI in production at scale now in 2025? And 3 out of those 10, I think, can be addressed with proper authorization, which is what we're going to do today. So very quickly, let's look at the different components in a RAG pipeline. So you can look at a RAG pipeline in 2 phases. One is the ingestion phase. So you have a knowledge base of documents, data. You put that through a preprocessor, which breaks it down into smaller chunks, which is easier to be read. And you push all of that into an embedding model. And that embedding model creates embeddings that you store in a vector database. For those of you all not familiar, an embedding essentially is a way to represent words and other data in numbers, because computers love numbers, and that's what they prefer processing on. So to give you an example, the numbers for king and queen are quite similar, but for king and raincoat might not be as similar, right? So there you can draw relations between different words and data. Very high-level overview. So that's the ingestion phase of a RAG pipeline. And in the query phase, a user makes a query, which again goes through the embedding model. That embedded query is then passed to the vector database, where you get the relevant embeddings, which include things from your documents. And lastly, you send that to an LLM to be processed in a natural language way, and you get a response back. Again, very high-level overview of what a typical RAG pipeline looks. You might notice something that's missing here is that there is absolutely no security or way to authorize anything here, right? So a user can ask a question like, hey, how much does my CEO get paid? And if you've not done the relevant authorization, you might get an answer. So essentially, your LLMs should not have access to unauthorized data. This could be in internal systems at enterprises, but also in systems that face externally to customers and end users. Turns out, a system like Zanzibar is actually ideal for RAG. Now, where Zanzibar-like systems shine is when you have scale, when you have a lot of data, when you have relationships between the data, and you know these relationships beforehand. Where a Zanzibar-like system is not good is where there's lots of dynamic data. Like, say, a HTTP filter, where you need to get information about IP address and HTTP headers and so on, which are all dynamic. It changes every time. Zanzibar isn't the best suited for that because you need to know some relationships beforehand. But for something like a RAG pipeline, it actually is very well suited. So we'll talk about how you can use a Zanzibar-like system in your RAG pipeline. All right, so there are fundamentally two ways you can actually secure your RAG pipelines with fine-grained authorization, and they're called post-filtering and pre-filtering. Let's look at the first one, which is post-filter. All right, so again, we're looking at a very standard RAG pipeline where you have a user, have a query, the query goes into an embedding model, and then that goes into your vector database. So you have done some level of getting the query, and now, post that, you can actually query your permissions database, right? Like your Zanzibar-like system. Remember earlier you could do a check permission? Well, that's what you do. Now, the interesting thing is when you're ingesting documents, you can actually add metadata. Sorry about that. You can actually add metadata to your vector database. So say you're ingesting content from a document with document ID 123. So you can actually correlate and add that metadata of document ID 123 into your vector database. So every piece of information from your document corpus has metadata about which document it came from, or an ID. So then, once you've got this information, you can make a check permission request to see if the user has permission to access that document. So this is called the post-filter approach. And of course, after this, you pass it off to the LLM, and the LLM gives the data back to the user. Now, typically, you would use something like this when you have a high positive hit rate. So say you have a fairly large number of documents. It wouldn't make sense if you're getting a bunch of them, and then you don't have to check for all, because that would make it very slow. But if you have a high positive hit rate, then for each of them, you can actually do check permission requests. So that's when you would typically use the post-filter approach. Today in the demo, we'll actually be doing the pre-filter approach, where, again, the user queries the embedding model, and you get an embedded query. And you essentially, instead of doing a check permissions, you look up all the resources that the user can access beforehand. So instead of getting all the data and then checking for permissions for each, here you're like, no, I'm going to find what documents the user can access, and after that, I will send it to my vector database. Right? So here in your Zanzibar-like system, you will do a lookup request and be like, OK, the user can access document 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We will send information from all of that into our vector database and then to the LLM, and then get the relevant information. So this is the sort of model we are going to be using today. And typically, when you have a very large set of documents, right, like say 10 million documents, this makes sense because you're typically not going to have a hit rate of 10 million documents. You look up, say, the 100 documents a user can access, and then send that to the vector database. So those are the two instances where you would use pre and post filter. So in today's demo, essentially, we are going to be using Pinecone as our vector database. Again, it's a tool where you can create a vector database serverlessly and add embeddings in there. We will use the OpenAI API as our LLM. We will use Langchain to create this embedding and the Langchain object. And we will use SpiceDB for our lookup request. I'm quickly going to do a quick prayer to the demo gods to make sure the demo works, because you know how that can go in conference Wi-Fi. But yeah, essentially, this is available on GitHub in a self-guided way. So maybe you can take an image or a photo. It's there in a self-guided way as a Jupyter notebook, so you can try it on your own later as well. And yeah, let's start with the demo. So the demo actually is fairly simple. We are not going to do 20 million documents, because my laptop will probably get fried. But essentially, we are going to have like a couple of documents with some information in each of them. And we'll see what happens when the user has access. And then we'll remove access, and then we'll query for that same information. Right? And you'll see how it goes. So let me just switch to my screen here. All right, so this is my Jupyter notebook. Let me maybe increase the size a little bit. So I have an instance of SpiceDB running locally in my terminal. Of course, typically you would have it running on a server or on Kubernetes. I'm just running the binary locally on my system right now. And every time we check for a permission to SpiceDB, you'll actually see it here. So I'll show you that as well. In the beginning, very Python stuff, just installing packages, etc. Here's the interesting part, right? So I said with a Zanzibar-like system, you have to define a schema. So we're defining a very simple schema here, where we have a user, we have an article. The relation between the two is a user can view this article, and there is a permission, which is view. Nothing super complicated, very straightforward. So we are going to write this schema to SpiceDB, right? And you'll see here it says write schema at 10:50 a.m. Yeah, so it's written the schema to my local instance of SpiceDB. And now, once you've created schema, you want to create relationships between documents and users. So we're going to use a fictional user and a document. So we've created a user named Tim. And we're going to create two documents, an article of object ID 123 and an article of object ID 456, right? Nothing major right now. We're just going to create these relationships. So let me run that. And you will see in SpiceDB, there is a write relationship that has just run. Yeah? Now, I'm creating a Pinecone index to store all my embeddings. I've already created this, but it's as simple as just these 5 lines of code. And it's using something called serverless, which is a Pinecone product. Going to the next slide, yeah. So now, I'm going to add some information to document 123. And I will add something silly that doesn't exist. And this is the text I'm going to add. Right? It says, Bill Gates won the 2025 Oscar for Best Football Movie. Now, there's no such thing as Best Football Movie. And if there was, I don't think Bill Gates would win it. But I'm just adding something fictitious so that the LLM is definitely not hallucinating and it's looking at this article. And this is the metadata that I spoke to you about, where I'm saying that article 123 contains this, and every embedding has metadata about where this data actually came from. So here I initialize a Langchain embedding object, and then I upsert all of this information into Pinecone. So if I go into Pinecone and I look at my index, I will see this information in their vector database. Let me do that. I think I've already done that, but I'm going to do that again. All right. So now that's done, I did say that we're doing the pre-filtration, right? So let me show you what we're doing. So we've done this part. So now we need to look up resources that the user can actually access, right? We are in this step. And we'll get a response before passing it off again to Pinecone. So let's do that. Yeah, that's here. So here, I'm calling the API for lookup resources. And I'm going to add it to an array called authorized articles and print it out. So let's see what it says. So you can see here that the article IDs that Tim is authorized to view is 123 and 456. Again, going back to SpiceDB, you will see a lookup resources right here. So it's made a call to the SpiceDB to say, hey, what can Tim actually access? Now, once that's done, we can start talking to our vector database and eventually to the OpenAI API. This is how a typical RAG pipeline would work. So I'm initializing a Langchain object for the OpenAI chat model. With Langchain, you can choose different LLMs. So you can choose Anthropic or whatever, right? All these different DeepSeek, all these different chat models. I'm initializing a Langchain object here. And here, this is the interesting part. I'm initializing a retriever with the filter that I spoke about. Right? So I've already got the articles the user is authorized to view, and I'm filtering it right here. And then I'm just doing some prompt engineering to say, answer the question below using this particular context from the retriever. And then I'm just printing it out. So the prompt here is, who won the 2025 Oscar for Best Football Movie? Hopefully this works. Yeah, so this goes to the OpenAI. Yeah, it said Bill Gates because it's reading from that document where we actually define this. So this is our RAG pipeline. Now, what we're going to do is we're going to remove this permission for the user to access this document, and we'll run the same query again. Right? So here, I'm deleting the relationships between the user Tim and the object ID 123, where we have that piece of information. Right? So let's run that. And if you look at SpiceDB, it says there's a right relationship here, which means it's run that. We can double check to see what documents Tim is authorized to view. So it's just 456. So he's not going to be able to read that piece about Bill Gates and the Oscars. And now let's ask the question again. Yeah, who won the 2025 Oscar for Best Football Movie? And it actually comes back saying there's no information provided in the context. Right? So when the user had permissions to read that document, we got information from that document. When we removed that permission, we didn't get information from that document. Right? So this is how you can actually do very, very fine-grained authorization on your RAG pipelines. Now, of course, this was for demo purposes, but the principles will remain the same when you actually scale this out into production as well. Typically, you would have your Zanzibar-like system running on, like, say, a Kubernetes or running on-premise or in the cloud. You would have multiple clusters of this running simultaneously. Those would have data in data stores like Postgres or Cockroach, where all these relationships are stored. And anytime you have to make a call for permissions, it would go into, like, say, SpiceDB, which would look up information from the data store and give it back to you. So in production, that's typically what it would look like. And yeah, congratulations on securing your RAG pipeline. Now, the interesting thing about this is you've done all of this, but it also has second-order effects. Right? A second-order effect is when you do something that has an intended effect, but the creation of that has an order of magnitude other effects. Sometimes could be positive, sometimes could be negative, but there are some positive effects here. One is because of the way relationship-based access control works, everything has an audit log. So say a file's permission has changed, that permission is logged somewhere. So later, if you're an enterprise, you want to check for audits and permissions, you actually can monitor every permission change in every file. At the same time, you are optimizing query response times because of the filtration. So instead of scanning like 10 million different documents, you can actually do pre-filtration, get the ones that the user has access to, maybe 100, 200, and then write to your vector database. So in a way, you're also doing this faster. And one question I get asked quite often is, hey, why are we using a permission system for pre-filtration or post-filtration? We can use OpenSearch or any like indexing and search tools. And the basic answer is, for permissions, you want to do a permissions or an authorization tool. And for search, you want to use a search tool. The difference can be not just in things like speed, but in the actual permissions itself. Because broken access control is actually at the top of the list of top 10 risks for web apps, according to OWASP. And there are some of these things, like in the Zanzibar paper, it actually describes something called the new enemy problem. The new enemy problem is when someone has access to a file, and they can access the file, and then their access is revoked, but they can still access the file because of a lack of consistency of data. Right? So there is a short period of time when a person who can't access a file actually is able to access it. And if you use, say, a search tool or a caching tool for pre or post filtration, you might fall afoul to this new enemy problem. So you want to use specifically an authorization tool which makes sure that the new enemy problem is actually solved. So that's why you want to use an authorization-specific tool for post or pre-filtration. Okay? So in a nutshell, that was what securing RAG pipelines for fine-grained auth looks like. For next steps, like I mentioned, this entire demo is on GitHub, and it's in a self-guided way, so you can do it step by step. Yeah, you can check out SpiceDB. It's completely open source. Feel free to contribute to the projects as well. And yeah, you can look at the docs, YouTube, or Discord to learn more. I have like about some time for questions, so happy to take any questions you might have. Oh, thank you.